Hey friends, we're back with our second video. So, Vaccines, Truth Over Tribe, Part 2. So, this time it's also going to be somewhat of a general video. Just a quick update. I went to the medical school library and found out that it's been a while since I've been there. And apparently, the huge long rows and stacks of medical journals that you can pull out and blow the dust off of and look at the journals in order to evaluate studies that have happened years ago, apparently that doesn't exist anymore. It's all done electronically, and it's done electronically from my computer. So I will be sitting here at this computer that sits right there and be going through a lot of studies in order to get to the bottom of a lot of these issues with regards to vaccines. So today, though, we're going to talk about some basic scientific study terminology. We're going to talk about quality scientific studies, because a lot of times we'll see in the literature that somebody will say scientific studies have demonstrated, or things like that. Saying scientific studies really doesn't mean much. It can mean essentially nothing. For example, it's kind of like saying if something is natural. Natural has a connotation that it's going to be good for us or something. But really, if you look at it, natural is like plutonium is all natural, right? That's not good for us. So just hearing that word, it gives us a certain connotation, but we have to realize that may not be accurate. The same thing is with the term scientific studies. So I want to talk a little bit about different scientific studies and how how different studies can have higher quality data. For example, the least valuable studies, or call them studies if you will, would be just like case reports. It means this is what's used a lot of times by pharmaceutical companies, for example, or not pharmaceutical companies, but supplement companies. Supplement companies will introduce a supplement, and then so-and-so takes it, Mrs. Thornberry takes it, and all of her arthritis went away. That's a case report. They get to pick and choose who they tell you about. Case reports have almost no value at all, because they're not evaluating everybody that takes it or a large percentage of people that take it. They're just telling you about the cases that they want to highlight. That has no value in scientific studies at all. Next on the level of getting slightly better would be expert opinions. Unfortunately, expert opinions are not oftentimes very valuable. And I realize I'm coming to you as somewhat of an expert, but I'm coming to you trying to be somebody that shows you the process as we go. But a lot of times an expert in the field, they may have a significant personal agenda or bias. And what I mean by that is, for example, if you work in a research lab and another competing lab has outdone you somehow, you might have angst towards that other lab. Like they may have come up with a description of a certain virus before your lab, or you may think that you had it first, but they did. And all of a sudden, everything that they start producing, you may have an kind of a intrinsic bias against them. This has happened a lot with different nutritional development studies and things like that over the years, where there became a rift in between lab partners or between labs themselves. And so sometimes those personal issues comes out in the form of expert opinions against that. And that's happened a lot with vaccines. There's been a lot of vaccine scientists that have been vaccine advocates, and then for whatever reason, they turned and became anti-vax. And they might have a good reason. That's what we're going to be looking at. But they may also have a kind of a personal emotional reason that has a strong bias and isn't really wrapped up in science. So least valuable would be case reports. Next least valuable or slightly more valuable than case reports would be expert opinion. And then we go to cohort studies. And a cohort study is much better than those two, but it's basically a good example would be what's called the British Doctors Study. And this was a study where in England they looked at a bunch of people that were smokers, and they compared them to a large group of people that were non-smokers. And no other variables were controlled or anything like that. And they just looked at them through the years to see if they tended to develop different diseases. And it's a way to evaluate certain features or certain disease risk factors over a long period of time. And it can give us some pretty valuable data. It takes a long time. It can actually, cohort studies can actually be retrospective studies also, where they look back through a group of people that's, if you look at those people that have lung cancer and those that don't, and then you kind of look back through the years to see what risk factors this group may have had or that group. The only problem with this data is that it can be very subject to patient variable biases, like, for example, if somebody smokes a little or smokes a lot, or if somebody was a non-smoker and then they started smoking, or if they have other variables like this smoker also, used other kinds of substances that might put them at risk, or they have high blood pressure. It's not controlling those things. And so there's a lot of potential for bad data, but it's still a little better than like case reports or expert opinion. All of that to say, what we're trying to get to are scientific studies that give us valuable information, that give us accurate information without bias. And that bias can be injected either by the study participants or by the researchers themselves or by whoever's funding the study. So what we're looking for is a way to get really good information that is free of bias. And one of the ways that we do that is to what's called a prospective, and you've heard these terms before, prospective, placebo-controlled, double-blinded, or let's see, prospective, randomized, placebo-controlled, double-blinded study. Sorry, my notes turned off here. Okay, so when all of these words mean something, and I'm going to go through each of them so that we understand it a little bit better. Prospective just means the study was designed to move forward. So you define exactly what you're going to study, and you move forward studying that exact thing. So prospective studies are generally better than retrospective studies. The next thing is randomized. Randomized means that you don't get to pick the people that go into the different groups. They get randomized. Sometimes a computer will randomly pick them or sort them. They get randomly selected and assigned to the different groups in the study. The next thing is a double-blinded, and double-blinded is, for example, let me give you an example. If you have a placebo-controlled study, it can be blinded to the participants in the study. So if there's a placebo, like the sugar pill and the regular medication that's being tested, the people that are taking the medication don't know if they're getting the placebo or the medication. Because if they knew, they could kind of change the outcome a little bit. They could say, oh yeah, I'm feeling a lot better, or it depends on if they have a bias towards that medication. So blinding it means that the participant doesn't know. Double-blinded means the participant doesn't know, and the researchers who are administering the study don't know. So there's a third-party entity that keeps all of these numbers secret. And it's basically they keep a key as to which participant numbers were assigned to which group. And that is only revealed at the end of the study, and it's called unblinding the study. So they get through the study. When the study's complete, then they unblind it to see what the results are. That way, it's completely unbiased from the perspective of the researcher and the participants. And that's why a double-blinded, placebo-controlled study that's a prospective randomized study is considered pretty much the gold standard for medical research. The next thing, though, is that there's what's called a meta-analysis. And that's even higher. A meta-analysis can pull data from multiple studies. And as long as those studies are very well done and well designed, then the meta-analysis might pull this information from the study done at this center and another country over here, and might have a prestigious medical center that does another study, and they all do similar studies, and the data is pulled from multiple different studies to even further eliminate bias and the potential for data tampering. So a meta-analysis can be the ultra gold standard. Now, all this to say, this is what we consider quality data. And there's a lot of studies that fall short of giving us quality data. The more issues or controls that you, or more factors in the study that you control, the less bias there is, and the least amount of statistical manipulation you have to do to try to eliminate the bias. Now, one other thing I want to talk about in this section, in this part 2 video, is that there's been a lot of talk about placebos, and some studies aren't placebo-controlled. It's important to know that not all placebos are the same, and they shouldn't be. For example, sometimes they talk about an inert placebo. An inert placebo oftentimes is just saline if it's a shot or a fluid. It can be a sugar pill. It can be different things like that. But it's got to be something, because you have to administer something for that person to feel like they potentially got that medication that's being tested. There's other kinds of placebos, because not always can you give an inert placebo for this example. And it's basically unethical to give an inert placebo in every instance. For example, if you have a vaccine that you've developed, let's say the hepatitis B vaccine. You develop the hepatitis B vaccine, and the first round of that vaccine, you find out that it's 85% effective. Then you decide, or another research group or another entity, they propose that there's a better way to do it that might get higher levels of protection and higher levels of safety. And so they develop another vaccine. Well, that vaccine, in order to test it, now can't be tested ethically against an inert placebo like saline. It has to be tested against the previous vaccine, because you've already determined that other vaccine was 85% effective at protecting these children or these patients from disease. So you can't subject this new group ethically to an inert placebo. That no ethics committee on an institutional review board to review your research would allow you to carry forth that research like that. So that's a situation where you would not be able to ethically have an inert placebo. So you may hear things in the social media about this hasn't been tested against an inert placebo. You're right, it hasn't, because there's a previous version of this that has to be used as the placebo in order to test effectiveness. Now, I know this is a lot of just kind of scientific talk, but I have to make these claims or make these statements or teach this part of it so that we understand these terms going forward, because we're about to launch into some slightly more technical parts of the vaccine debate, and we have to keep these other things in mind, because so much of the misinformation out there is taking advantage of the fact that you don't know the difference. Well, we're going to make sure you know the difference so that they're not taking advantage of you and I anymore. Hope that helps. Now, until video, let's see, vaccines, Truth Over Tribe video number 3. Until that one comes out, it's been nice seeing you again. Take care, and I'll get busy on this next video. Okay? Take care. Bye.